Okay, hi guys. I hope I'm audible. Let me just check if I am streaming live or not. Then we will start. Okay, just a moment. Yep, we are live. Okay. Hello everyone. Welcome back again to our channel Coders Arcade. This is Saurabh, and today we are back again with our Java DSA live sessions. Okay. So once again, very simple. Those who are new to the channel, those who will be coming new, please subscribe to our channel, and those who are already there, you know what we have already completed, right, till yesterday. So we have actually done linked lists. We have started linked lists and solved some problems also, and we have seen some algos also, correct? So if you remember, yesterday we had learnt about a very important algorithm called the Floyd's algorithm, and I told you how to use that to solve a lot of questions. So everyone, whoever is new, just welcome to our channel. This is Java DSA Live. Okay, and we are at Coders Arcade, our YouTube channel. Okay, and we have started the playlist and we have started linear data structures, which is linked list. Okay, we have started singly, and then in singly linked list we were solving some problems also. But yesterday, if you remember, we did not cover the add last method. So what I was talking about, guys, yes, in the insert or the add operation in the linked list, we had done for the first or the head or the front, you can say. This was done, and then we had done it for the tail also, or you can say last, or you can say end also. These two were done. Now we need to insert at the this was also done, and I think we had done one more thing, right? We had done the remove operation also, if you remember. We had done the delete operation or remove operation for first and last. These two were done, correct? One was pending. What was pending? Delete target. Delete target. For example, I have a linked list 1, okay, Roman numbers only I'll write. Does it matter? No. 1 2 3, 1 2 3, and then null. I want to delete this one. What? That particular one, which is 2, for example. This one I want to delete. To delete that, obviously the new linked list that will be there, head is the only way to refer to our singly linked list, right? So if I delete this one, the new linked list will become 1, then 3, then null. Got it? This will be the idea, but how will you do it? I think blue eyed boy says good evening. Insert add element in the middle. Yes, this one. This one, remember I told you, I hope I have showed you how to find the middle. Blue eyed boy, find middle I have told you. Can you just try the insert operation based on that? Because once you find the middle, you have to connect the previous and the next. Then based on that, easily you can insert at the middle. Okay, I have told you how to find the middle node. Based on that, can you try to do it on your own? If you can, then it is well and good. Otherwise, I will tell you how to do it. Okay, I have already showed you the Floyd's algorithm. Floyd's algo for finding the middle, the slow and the fast pointers. Try to do the insertion with the help of that. If you can't, let me know. I will do it in the live session only. Okay. Okay. Now, as I said, let's try to delete a target node. So for that, what we will do is, we'll just write down something like this. Okay, I think I have not connected this one. Is it? It's connected only. Just a moment, guys. one moment. Okay. Just a moment, guys. Okay. Yeah, actually it was about the internet. Okay, so I think now it is fine, and hope you were able to. Okay, I hope I'm audible now. Guys, just respond by saying if I'm audible or not. Okay, all good. So sorry for the disturbance. Actually, that was the internet. So what is the target now? I have 1, I have 2, I have 3, I have 4, and I have null. Here I need to delete a target value. Okay, let's write down the code, and based on that we'll decide. Let's write down the prototype. Okay, so this was our code, and guys, still I am waiting for a response. Nobody has told me to share the code. Okay, and only 1 or 2, बाकी लोगों को नहीं चाहिए शायद कोड. ठीक है, मेरे पास ही रहने दो. So here I need to remove the last node, correct? So I think there is no comment at all. All good, we are good to go. So let's start. All fine. So what I'll write public void remove target. Okay, and obviously I don't need any argument. I need an argument. The argument is the target, and because my linked list is a string linked list, so I'm writing like this. Okay, so some simple idea. What is the simple idea? If it is empty, I cannot remove the target. So that code I will have somewhere. Let me just copy that from here. Yeah, this one. Copy this. This one everyone will know, right? If the linked list is empty, can't delete the target. You can write the target node. Rather than writing last node, write target node. Okay, got it, and return. You cannot do anything. And next, after that, just think like this. The target is at the head. First option, the target is at the head. One is the target. Here head is this and target is as the head. How will you do this? I need to delete this target. Once I found this, so it is like head dot data or head dot value is equal to the target. I need to move the head to the next node because then only it will get deleted. Correct, very simple. So head equal to head dot next. So I will use the this keyword. Correct. शेयर कर देना कोड सर. यस, ब्लू वाइट बॉय से शेयर कर देना. डेफिनेटली कर देंगे, बस रिस्पॉन्स के लिए वेट कर रहा है. जस्ट वेटिंग फॉर ऑल योर रिस्पॉन्सेस. तो पक्का बिल्कुल शेयर कर देंगे. Okay, and so this one I got, you understood. So move the head to the next node so that you can delete the target from the head node. Okay, so I'll just say case where the target is at the head node. If our head dot data is equal to the target. Okay, see, this is not recommended sometimes. I will tell you a very important question here. I am writing target. This is not a good practice, and see, I have got a warning here, guys. ये सब जानना ही ज़रूरी है in the interviews. Okay, when I am doing this, see what is happening. String values are compared using equal, not equals. It is showing you a suggestion also. We should use the equals method of the strings. So I'll say dot equals, and then I will pass another target like this. Okay, got it? And now I'll give the bracket. Got it? This is the best way to compare strings, the dot equals method. Don't use equal. Equal should be used for other properties like integers and all, you can use that. Okay, then what do? Head equal to head dot next, correct? And because we deleted one value, what should be the new size? It will be size minus, decrement the size. Okay, and return. Okay, got it? The first case is solved. No doubts till now? All good? No problem. Okay, next case. Target is somewhere in the middle. Okay, just remember this, very important. Let's write down the code or the pseudo code so that you can also understand. Let's take something like this. This one you understood. Let's scroll it up and write it down again so that you can understand even better. I have 1, I have 2, I have 3, I have 4, I have 5, and then I have null, and I need to delete say 4. Target is 4. So can anyone tell me the approach? What should you do? I am just looking at the phone also to see if there is any comment. Right now there are no comments. Guys, these are the things that you will need while solving questions also. See, find the middle node, delete the middle node, all these things. Similar thing. This is a target node. You are deleting a target node. Obviously, if you can delete some target, you can also delete the middle node also. You find it and delete it. Okay, how will you do this? What is the approach? Anybody? Can you help me? Tell me. Orange. Just waiting. See, what we can do is, I will take a current pointer. This is the head node. I will take a current pointer which will point to the head node. Okay, and I will take a previous pointer which will point to null. Okay, and now see the idea what I am trying to do. Okay, let me have this target here. Now see what I am trying to do. Okay, I will say while my current is not is equal to null, and try to understand current dot data dot equals, let me write it to a little bit that side, okay, because it will become a bit ugly otherwise. थोड़ा इधर लिखते हैं इसको, okay, यहाँ पे current dot data dot equals what, this one, target. Okay, so while my current pointer is not null, what I will do, I will say current is not equal to null and current dot data equals target. No, not equal, mind you. I will write this not operator. That means till I get the target, I will keep on moving. But suppose I have a target called 8. 8 is not there in the list, then current will become null. Then I will check if the current is null. I did not find the target, I cannot delete it. The target is not available in the list. Okay, did you understand what I am saying? So in a case when the current becomes null and you did not find the target, you will just write that you did not get it. Otherwise, see this, what I will do is, because yes, while current of position is not equal to position minus 1. Just try to understand this, that is also fine. Just try to understand, this is more easy actually. Okay, so now when I have written this, then what will I do is I will traverse one by one. So I will just say this one will move here, previous equal to current and current equal to current dot next. And this is your looping statement. Fine, just try to analyze. Okay, I will just traverse and show you, dry run करके देखते हैं. Current is not null because current is at the head, correct? I will write current equal to head and previous equal to null. ठीक है? Now current is not null, true, and current dot data is not equal to the target. Not operator I have used. नहीं है, 1 is not equal to 4. So what will happen? Previous equal to current. So previous comes here and current goes here. Current equal to current dot next. Correct? Let me write completely. Previous and current. Again same thing. Current is not null and current data is not equal to the target. Obviously 2 is not equal to 4. Okay? 1 not equal to 4. 2 not equal to 4. We keep on moving. Then what happens? Previous comes here and current comes here. Got it? Now again current is not null, current of data is not equal to the target. Got it? So what happens now? Previous will come here and current will go here. But now observe carefully. ध्यान से. Current is not null but current of data is equal to the target. 3 is not equal to 4 was skipped. Now 4 is equal to 4. True. What will you do? This loop will stop. Now observe, my current pointer is at the node which I want to delete, जिसको delete करना है, okay? And my previous pointer is at the previous of the current. Why do I need this? Very important. Once I delete this current, this has to be linked here, right? The linked list cannot go become destroyed. I need to keep the data intact. Only thing is the node I need to delete. Got it? So what will I write after this? I will just write, see, this is my current now, here current, and current dot next is this one. What I need to do is my previous dot next should be equal to current dot next. Try to understand, okay? Very important. ध्यान से देखो. I will write something like this. Previous dot next is equal to current dot next. Why? What is previous? Previous is 3. Okay, 3 dot next equal to what is current? Current is 4. 4 dot next. Okay, try to understand. 3 dot next is connected to 4 dot next is what? 5. Got it? That is how you connected these two. Is that clear? That is how we are keeping that intact. And this 4 will be deleted by automatically. You don't have to worry about that. Is that clear? Hope it is clear now. The same logic you will be using every time. I hope you have understood this whole traversal. Any doubts, let me know. That is the very simple thing about it. But imagine the target is 9, 10, 100 something, that is not there. At any time the current will go and become null. Then we did not get it. That line also you have to write, okay. So here I will check if my current is equal to null. That means target not found. Target not found. Got it? Otherwise do this. Previous dot next equal to current dot next. Got it? That is how it will work. So let's write down the code now. This one was the case target is at the head node. Now target case target is anywhere in the list, doesn't matter. Now as I said, we will take node of previous is equal to null and node of current is equal to head, and what was the loop? While our current is not is equal to null and current dot data dot equals target, okay, and here I will write not is equal to. Okay, what will you do? You will move the previous to the current, previous equal to current, and current is equal to current dot next. Make sense? Is that clear? I hope this one was easy to understand for you guys. Okay, any doubts you can let me know. That's all guys, this is the code, and now after that we need to check, right? Check what? If the current has become null, we did not find the target. So I'll just write if my current is equal to null, what? S out, target not found. Okay, and because target was not found, just return. Don't do anything, just return. Otherwise, the same logic, this logic that we have written, previous dot next will be equal to current dot next. Current is 4 dot next 5. That is how we'll connect them. So I'll write previous dot next will be equal to current dot next. And also we deleted something, size minus minus. We are keeping track of the size also. Okay, so here I'll just say adjust the previous and the next links, node links, you can say node links. Got it? Makes sense? That is how it will work. Okay, I hope you have understood this. Now let's verify this. I'll just say let's print the list first and let's see how it was looking like. Okay, so you can see channel Coders Arcade has 50k null. So let's delete has. Okay, I'll call list dot remove target. I will pass the target like this. Say what? I'll write down my name. My name does not exist. So if I run this, let's see what happens. It should say does not exist, target not found. Very good, it's working. Okay, let's write down list dot remove target. This time I will write has is available. So after that, let's list dot print list, print also, so that you can see if it is deleted or not. Let's verify. Yes, see, Coders Arcade has was there, has is not there. Okay, that is how you use the delete operation. Very important. Got it? I hope you have understood this. Any doubts you can let me know. ठीक है? Yeah, blue-eyed boy says clear sir. ठीक है. I think this was easy. Hope you understood this. ये ज़्यादा आसान है. Rather than confusing ourselves, this is a very easy method to do it. Take a previous pointer, previous queue, because once I delete this, I need to connect the previous to the next. That's why I just keep a track. If you don't keep a track, you may lose the linked list. That's why you have to keep a track. Got it? And this is the pseudocode. You can see here. This is the basic pseudocode. Okay, clear? Now, so with this, we have done the basic idea of the singly linked list. Almost all the things have been covered. Okay, and then let's do one thing. Let's go to a very interesting question that is very frequently asked in the interviews also. Okay. Many a times this question has been repeated in the interviews. Palindrome linked list. Maybe some of you have already solved this. So I had already given you the idea. Okay, I had given you the idea, right? Palindrome linked list. Simple example. 1, 2, 3, 3, 2, 1 and null. One more example, 1, 2, 3, null. The first one, if you see, 1, 2, 3, 3, 2, 1. This is a palindrome, and it is a palindrome linked list also, because the structure is a linked list. The second one, it is not a palindrome, 1, 2, 3, null. It is not 3, 2, 1. 1, 2, 3 should have been the reverse way also. So if you traverse from the beginning and if you traverse from the end, they should be same. Okay, similar here also. But the problem is we cannot traverse this linked list from the rear end, right? Not possible. So what you do is you can take a stack and insert traversal 1, traverse the linked list from the head, taking a pointer, say current, take that, insert the elements 1, 2, 3, 3, 2, 1, traverse, and from the stack remove the elements one by one, the top elements, okay, remove 1, compare, matching, remove 2, compare, matching. So you have to do one more traversal, T2, okay, remove 2, compare, remove 3, compare, matching, remove 3 again, compare, matching, remove 2 again, compare, matching, remove 1 again, compare, matching. All are matching, you will return true. Other case, the second case, traversal 1, 1, 2, 3, got it? Stack, remember, stack, last in first out. Now traversal 2, top element is this, remove 3, not matching, there is a mismatch. The data here and the data here does not match, return false, finished, end of story. That is how you will do it, very simple, right? So always in case of reversal operations, we mostly use a stack because of its last in first out operation or property. Okay, hope you have understood this. XYZ, in the interviews you will never write the implementation, not required, you will never write the implementation, okay, you will not write that. Okay, you will not be writing the implementation in the interviews, don't worry about that. Only if they mention, then you will write, otherwise you will use the collections that I have given you, the libraries, right? If you see here, the collection libraries have been given here. If I open this, see, I have given array list example, this is the collections one, shortcut, dot add, and this is the linked list example, this one. I have given you this too, you can use this too directly, okay, don't have to worry about that. But if they mention to do the implementation, then obviously you have to do it, you don't have any other choice. But if they don't say anything, always go for the shortcut, the built-in data structures or the collections framework, okay. So that should be your target. Hope you have understood this. Just waiting for anybody to say anything. Yes, everything is clear, I guess now. So this, hope you understood this one, the basic idea how to take a palindrome. So now let's do one thing, let's execute this and verify how to write the code, okay, because I will use a stack, a built-in stack, okay, the stack from the collections. So let's go back to our code and write down. What I will do is I will create a new package, okay. So cycle detection was done, and let all this be like this. In singly linked list only, I will create a new package saying palindrome. Inside that let's create the class called palindrome linked list. Okay, and let's create the template first. I'll say class list node, and let's take integers only in data. Okay, and obviously this is a singly linked list, so I'll only have the next pointer, and now take the constructor, take the data from the user int, sorry, and this dot data is equal to data, and let me remove this unused import statement. And what was the next thing that we needed? The next thing that we needed was this. By default, the linked list nodes will not be connected to any other nodes. Okay, so I'll just say this dot next is equal to null pointer, null. Got it? This structure you already know. We have done it a lot of times now. Now the Bayes idea. Put everything, traverse the linked list one, put everything into a stack, remove everything from the stack one by one and compare it with the linked list again, the second traversal, T1 and T2. If I show you here, T1 traversal, remove everything, put it into the stack, again pop everything from the stack and compare. If they are matching, true. If anyone is not matching, false. Okay, got it? What is the time complexity and space complexity of code which you explained? See, we are traversing, very good question, XYZ. We are traversing all the nodes, correct? So obviously it will be big O of n, correct? Because there are no nested loops, we will not be using any nested loops. Because we need to traverse all the nodes and put them into the stack, it is O of n, the time complexity. And stack, the stack is also called a recursion stack. Okay, for the stack also we are using all the n elements. So for the stack also the space complexity is O of n. Okay, the TC is O of n, the SC is also O of n. Got it? Because we need the stack to store the elements. For that also it is O of n. Okay, I hope you have understood this. Now let's write down the code. So I'll write down a method, say public static we are checking palindrome or not palindrome. So boolean is palindrome. Okay, and what will be passed to the linked list? Passed to the method, it will be the head. Okay, got it? I hope it is clear. So this was the structure. Now I need to write the proper implementation. So I'll take a stack. See guys, I'm teaching you collections here only. I've done that earlier, but I'll write it again once again. So okay, no problem. Yeah, XYZ says good. So I'm taking a stack from java.util. Okay, and bracket. I'm taking integers, so I'll take integer, and stack is equal to new stack. Okay. Stack is a class, queue is an interface. I have already showed you last time. Now I need a node, temporary node, which will be pointing to the head. After that I will travel. Okay, so traverse the list first time to push all nodes into the queue, sorry, stack. Okay, clear? So I'll just say while our temp is this, you know already, right? Temp is not is equal to null, keep on traversing. Stack dot push that element. What is that? Temp dot data, correct? And temp is equal to temp dot next. Keep on going to the next data. Got it? This is the basic idea. Now we are not done. Now we have to traverse again. Now compare the nodes with the stack elements. Okay, so now again I will traverse like this. But just remember one thing, guys, very important point. See this. The temp was here or the current was here. Once I traversed, Current came here, came here, came here, came here, came here. We pushed all the data 1, 2, 3, 4, 5, 6, all the data. Where is current now? Null. To do the second traversal, I need to bring the current again forward here, right? At the head. Correct? Otherwise, how can I again compare? So, what I will do is, I will just write bring the current to the head, okay? Bring the current. I have written temp, right? So, temp is equal to head, okay? Then, while our temp is not is equal to null, what will I compare? I will compare the stack element like this. Which element will you compare? Tell me, anybody? Will compare the list element with the stack dot top always, okay? So, I will write something like this. Excuse me. If my temp is at the beginning, okay, temp dot data is not is equal to stack dot top. Pop will remove the last element, right? That is also fine, no problem at all. What do you return if they are not equal? Our target is equality. If it is not equal, we will return false. Just return false, don't do anything. And otherwise, keep on traversing to the next. If it is equal, keep on going, temp equal to temp dot next. Got it? And then, if the whole thing is over, what will you return? True or false? True, obviously. Look at the diagram. I covered this, I covered this, I covered this, everything is fine, return true. If I stop anywhere for the second example, then it will return false automatically. Got it? Okay, I hope this is clear now. No doubts at all. Let me check if there are any comments. No comments as of now, so it's good to go. Great. So, I hope you have understood this now. Clear? So, either return true or return false depending on that. Now, I need to form the list, right? Let us create a simple list so that you can understand. Main method, create the list node head is equal to new list node and the data say 1, okay, and I am just forming like this, head dot next equal to new list node 2 and let us say head dot next, the third element equal to new list node. This time I am writing 1 to 1. 121 is a palindrome. So, I will just say S out is palindrome. Our head question mark, if it is true I will print palindrome. I am trying to use ternary operator, okay, or else what will you write? Not palindrome. Got it? So, according to this it should be a palindrome. Let me run this and check. Yep, it is working. Palindrome. Got it? Otherwise, very simple. Let me just change it to 3. 123 is not a palindrome. Not palindrome. Here you go. Hope you understood this. No doubts, right? Okay. So, this is how you can check this. Very easy, very simple also. No comments yet, all good. So, fine. Okay. Anybody, anything, you can tell me. Otherwise, we can do one thing. Yesterday, I think someone told me that he found problem in doing something like this. What is that called? That question was reverse in groups of k. That question is not that tricky if you can do the analytical observation of the question in a very simple way. Okay, let us try to understand that. because this question was asked, so what I am doing is I am trying to give you the question. The question says reverse linked list in groups of K. Okay. To know this, you should know one more thing: how to reverse linked list. Yes, that also you should know, right? Then only you will be able to do that. Obviously, if you don't know how to reverse a simple list, how can you reverse the whole thing? Not possible. So 1, 2, 3, null. How do you reverse it? The output should be, this is the input, this is the output. It should be, yes, 1 is the head, 3 will become the head. Okay, so it should be 3, 2, 1, null. Okay, and here you go, this was the head earlier, now this is the head. Anybody, can you tell me how to do this? This is a very important question that is asked in placements, guys. Reverse in groups of K. But for that, you should know how to reverse this. Anybody? Tell me. Just waiting for your response. Anybody, if you can tell me. Just waiting. Nobody says anything. And guys, always, as XYZ has suggested, please for every algo, see the time complexity. That is a very important part also. The interviewer might ask you sometimes, what is the time complexity and the space complexity of the code that you have written. At that time, you should be able to analyze what you used, what data structure you used, how it is working, everything you should understand. Okay, here, sir, can we use 2 or 3 pointers? Definitely you can use XYZ. Definitely you can use. Yes. How you can use? You need 3 pointers actually. That helps you a lot. You can take a previous, you can take a current, and you can take a forward. That is how you can keep track of that. Okay. Can you tell me what logic you can use? Just a moment, guys. Let me check one thing. Anybody? Do you get it? Did you get any idea how to do this using 3 pointers? Okay, let's see this. Try to understand. I have 1, I have 2, I have 3, and then I have 4, and then I have none. Okay, as we said, very famous approach, it is the 3-pointer approach. Three-pointer approach. Okay, how? I am taking a previous value is equal to null, I am taking a current value is equal to head, and I am taking a forward value, or you can take node next also. Forward is also equal to, this is head, okay, this is my head value, and this is forward equal to null. For the timing I am writing like this. So what actually I am trying to do, my previous is here and my forward is also here, both pointing to null at the beginning, they are pointing to null and null. Okay, this is null and this is also null as I have written there. So what you do, you just try to, because see, the target will be 4 3 2 1 null, right? So in that case, once I make this point to null, I cannot lose content of the, I cannot lose the linked list. This part I cannot lose, right? I need that. So I need to store that into a variable. That's why I have taken the forward variable. Okay, got it? So if you try to understand this, we will write something like this. Try to understand. I am writing while, just a moment, I think, yeah, no comments at all good, fine, no problem. So while our current is not is equal to null, what you can do is very simple. See, I am writing forward is equal to, forward was null, forward will hold current dot next. My current is here, okay, current dot next. I need to hold this, then only I can make this 2 point to null. Okay, forward equal to current dot next, got it? And the previous will go to the current. Try to understand what is happening. The previous will go to the current and the current will go to the forward. Current will go to the forward. Okay, and this is your loop. So try to understand what is happening. What I did, first current is not null, true, current is added, not null. Now forward equal to current dot next. So forward was null, forward is here, this is current dot next. Very good. Now previous equal to current, the previous came here, and current equal to forward, current came here. Is that clear? Got it? That is how it is working. And next, try to understand. Again see this, current is not null, forward equal to current dot next, forward comes here, got it? And then previous equal to current, so previous will come here and current equal to forward. See how we are moving, got it? I am keeping track of the values also. Similarly, last time current is not null, true, forward equal to current dot next, forward comes here, got it? Is that clear? Now next, try to understand. Previous equal to current, previous comes here and current equal to forward, got it? Again, current is not null, forward equal to current dot next, magic, see, forward equal to current dot next, forward comes outside, previous equal to current, previous will go here, and current equal to forward, current is also gone, got it? Now this is the value previous that is stored here, previous, that will be your answer. Is that clear? This is the algo used there. Okay, let me know if you have understood this. Simple logic, just push it like this so that you can create a logic like this. And what did I say? We should return the previous. Guys, there is a link lead code question based on that. Let me just check if I have that question somewhere. I will show you. Should be there. Here, let me just open that. Yes. Reverse a linked list, lead code, this question, this one only. See, this is the question, and yes, got it? Very simple idea. So as I showed, let's try to write down the algo and see if it is works or not. Okay, and guys, if you remember, we have to consider some base cases also, right? So what we can do is we can write some base cases. Can anyone tell me in the comments what will be the base cases? Anybody? What if the linked list is empty, that is head, this is Java only, head equal to null, or there is only one element, one null, it will be same only, there is no need to do anything. Head dot next is equal to, let me see how it is written. Okay, they pass the head only, head dot next is equal to null. In that case, empty or single element, I will just return the head, I don't need to do anything. Okay, got it? Fine. Otherwise, I will take, what did I take here? This is the node, list node. I'll copy this list node of previous is equal to null, and list node of forward is equal to null, and list node of what? Current is equal to which pointer? Head pointer. Got it? Now what we are doing is, let me just drag it a little bit up so that you can also see this. I hope you can see this. So what you will do now, as I said, while my current pointer is not null, what we are doing, current equal to forward equal to current dot next. We are just trying to hold this data, right? We are just trying to hold this as long as we keep on reversing, holding this, reversing this, holding this, reversing this, right? So forward equal to current dot next. Okay, and if you are writing this in C++, you will have to write an arrow. Okay, here it is okay, and then previous equal to current, and current equal to forward. Got it? And this F I need to correct this. Got it? And this will do. And finally, as I said, after the loop is over, you should return the previous. That should do it actually. So this should be the algo. Null not next, return head, previous null, list node forward null, current. Yeah, let's submit this and see if it is working or not. Compilation error, semicolon. Where did I not write a semicolon? Okay, sorry, my bad. Check. Wrong answer. Can anyone tell me what's wrong? 5 4 3 2 1. Can anyone tell me what is wrong here? What was the case? Let's see. Why is it wrong answer? Case 1, case 2, case 3 is working, empty is working, case 2, 1, 2, output is 2. What have they told you? Give the head of a single linked list, reverse the list and return the reverse list. Okay. Guys, can anyone tell me what has been done here and what can be wrong here? Anybody? Please tell me. Good. One question we have got, 1 point we have got. Anybody? Anything else? Just waiting for your answer. Anybody? If you can tell me, because normally this should work. Why is it not working? We have got a failed test case here. You can see for one test case we got the wrong answer. This one 1 2 3 4 5, the output is 5 actually, right? So I need to return what? Reverse list, right? So previous should be correct. Forward equal to current dot next. This line is not correct. Yes, one line we have missed, guys. Very important. See, I'll tell you one thing that we have missed. Try to understand, okay? I have written forward equal to current dot next. Try to understand. I have written forward equal to current dot next. That means I stored this here, but this current value should be connected here, right? Current will go this side because 1, 2, 3 was like this. So now 1 will point that side, 2 will point that side, ulta, right? That connection we have not done. So one line extra we have to write, that is current dot next is equal to previous, that line we have not written, then only it will work, right? Otherwise, here one more line is there. So, this line current dot next will be equal to previous. This should work now. Now, previous equal to current and current equal to forward, so that you can go on to the next values. Let us check if it is working or not. Now, it should work actually. Yes, it is working. See, I told you, right? That line actually we did not do the connection only properly. Now, if I submit this, it should also accept that, because all the test cases are passing. Yeah, it is working. See, everything is fine. Got it? So, this is the logic. So, what I missed out is I am saying hold the next one, connect the current to the previous one, so that the direction is changed. Okay, that is how it is working. Okay, this is not required. Hope this is clear, right? Now it is clear. This is the whole solution. Hope you have understood this. Correct? And based on this, guys, you have to actually do what? Solve the next question. Reverse in groups. So, when you know this logic, so I will just give you a simple dry run, okay guys, otherwise you will also get confused. So, I will just say, let us do one thing, give a proper simple dry run, so that you can also understand what we are talking about, because otherwise it will be like we are learning something wrong. 1, 2, 3, 4, 5 and say null, okay, and then this is my previous, which is outside, and then I have forward, which is also outside, and then this is my current at the head node, okay, previous, and this is null, this is also null, okay, blank. Now, what I am doing is I am writing while my current is not equal to null, correct. What we are doing is we are saying forward equal to current dot next, okay, forward equal to current dot next, I hold it, I hold that number, and then I am saying current dot next, actually it was here, now it will go to previous, to null, correct, equal to previous, then only actually what is the target, 5, 4, 3, 1 null, that is when this side it should go. So, and then now previous equal to current and current equal to forward, got it? This step we are missing, that is why it was not working out. I hope you have understood this now. Now, see, now what will happen, forward will come here, and yep, this is correct, current dot next, and then previous comes here and current comes here. Similarly, forward comes here, previous comes here, previous will come here and current will come here. Gradually it will keep on going, forward here, previous here, current here, forward here, previous here and current here. After that, if you see, current is not null, good, well and good, and it is automatically connected. Here in this line only, this got connected to null automatically, correct, it got connected to the null value. After that, if you see, current is not null, so it will keep on going, current will go here, again forward will go here and previous will go here, correct, that is how we got the connection. So, establish, hold this connection, establish this ulta connection, and then keep going forward, so that hold, reverse, hold, reverse, hold, reverse, that is how it is working. Okay, I hope you have understood this now, and this has been solved here also in the question, in the lead code question here, got it. Now, you have to do the same thing for a group, got it. Now, try to understand this, reverse in groups of k. So, here what we are doing is, try to understand, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6 and I have 7, and then say suppose I have null. This is the target, and say suppose the group K is 3. Okay. So, what you do, simple, for the first one only we have to bother about this, because I need to return the head is very important. Okay. So, what will happen here, for the first 3 groups, K equal to 3 I have said, right. So, this 3 I know how to reverse, logic is here. After reversing, it becomes how much, 3, then 2, then 1. Head will get updated, head has to be here. So, for the first one you have to be very correct about the head, because you will return that head only, this will be returned from the function. Okay. After that, here see, I have to count groups of 3, 1 2 3 1 2 3, this is one more group. Again simple guys, recursion, pass that value, take a temporary value from here, keep the temporary, temp will go here, temp will go here. How will you calculate the group? Take a count variable, count is less than k, count equal to 0, keep on going, count plus plus, go to the node, temp equal to temp dot next and count plus plus, got it, and automatically will get the count reverse. Call the reverse function, reverse that. Similarly, temp will be here, take the count, reverse. After that, when you have reversed this, it will become how much? What will it become? 1, then it will be 6, 5 and then 4, got it. After that, when you go to the next one, when temp comes here, what will happen? The size is less than k, cannot reverse, just return that. So, after 4 it will be 7 and then none, got it. That is how it will work. I hope you have understood this. So, once you have reversed, then only you can apply on a group of k. Very simple guys. Try to write this, if you can't, tell me, I will solve it in the class only. Any doubts, let me know. Okay. So, I hope you have understood this and clear. Guys, what we will do is, we can wind up for today. Tomorrow we will be learning about doubly linked list and circular linked list. Okay. So, this was the algo about the reverse algorithm, how to reverse a linked list. After that, we have seen how to reverse in groups of k also. I have given you the idea, basic idea how to do this. Try to solve this, and if you can't, let me know in the comments only obviously, then we will solve it again. Okay. And yes, thank you for being with me, thank you for understanding, thank you for giving your comments. Hope you are loving the content. If you have anything that you need extra, please let me know. And yes, we are going in a very good journey, we are learning a lot of things. So, stay tuned, be here, and those who are new to the channel, please subscribe. Okay. And thank you for watching. Till the next time, this is Saurabh signing off. Bye bye and happy learning. Thank you. Bye.